I wish to stop.
Hello and welcome to this video. Today we will look at the history in the Carillon Historical Park Museum. Today we will be exploring the modern day, the 20th century of Dayton, Ohio. Here we go. National Cash Register, NCR, produced many durable mechanical cash registers in the late 19th and early 20th centuries that became standard equipment in stores across the United States. Early 1900s models typically featured ornate cast metal construction, mechanical key-operated mechanisms, and printed receipts or transaction records to improve accuracy and reduce theft. Founded in Fort Wayne, Indiana, in 1918, Frigidaire became a leading appliance brand after its acquisition by General Motors. Today, the brand is owned by Electrolux, which continues to manufacture appliances under the Frigidaire name. Delco's humble beginnings in the carriage house before he grew into a multinational, multi-billion-dollar branch of General Motors, with operations in dozens of cities around the globe. Dayton's strong feast to GM included such divisions as Delco Marine, Delco Products, Inland Manufacturing, Frigidaire Marine Assembly and Aero Products. General Motors' Aero Products division began as Engineering Products Incorporated, a company founded by W. J. Blanchard and Charles J. McNell in 1935, which specialized in the aeroprop propeller. The aeroprop propeller consisted of hollow, rib-reinforced steel blades that applied new principles of pitch control in a hydraulic and lightweight fashion. On the eve of World War II in 1940, General Motors purchased the fledgling company and formed its Aero Products division with W. J. Blanchard at its head in an initial plant in Vandalia, Ohio. On the day of the attack on Pearl Harbor, the plant was within its first full month of production and output increased as the war progressed. The simplicity of the aeroprop propeller made it easy to produce and it became the top choice for propellers during the war. Following World War II, the aeroprop division produced propellers for peacetime affairs, the Korean War, and other General Motors PSA. Upon the invention of jet-propelled aircraft, the Vandalia plant was discontinued and acroprops became less prominent, leading into the 1970s. After its retirement from Aero Products, the plant in Vandalia was acquired by the GM Inland Division, and later became the Delphi Chassis Vandalia plant. The Cadillac Automobile Company, organized on August 22, 1902, followed the Hogan craftsmanship creed, accuracy, a law diligently under the direction of its president, Henry Martin Leland. By 1908, when General Motors had formed, Cadillac had secured a position of eminence in the automotive world. After Cadillac was acquired by W. C. Durant's General Motors Company on July 29, 1909, Leland continued as Cadillac's president and his pursuit of automotive excellence grew ever stronger. The mutual desire to relieve the need for cranks starting a car spurred Deeds, Kettering and the young Delco firm to their triumph in electric ignition for the 1910 Cadillac and their greatest achievement, the electric starter on the 1912 model. The original 1912 Cadillac touring car in front of you is an example of the first production vehicle built featuring Delco's electric ignition, starting, and lighting system. Built in Detroit, Michigan, this car is equipped with an L-head, inline, 4-cylinder, 40-horsepower engine with 286, 3 in displacement. The Dayton motorcycle was introduced in 1913 by the Davis Sewing Machine Company of Dayton, Ohio, following their successful production of Dayton bicycles during the 1890s bicycle boom. To power these heavy-duty machines, the manufacturer utilized robust 9-horsepower V-twin engines sourced from the F.W. Spack Machine Company of Indianapolis. These motorcycles gained notoriety for their raw power and durability, even participating in high-profile historic endurance events like the 300-mile Venice race in 1915. Production was ultimately short-lived, concluding around 1917, which makes survivors like this exceptionally rare pieces of American motorsport heritage.
The Manhattan Project was a top-secret U.S. government program during World War II that developed the first atomic bombs. Dozens of military and industrial sites across the United States Canada, and the United Kingdom were a part of the Manhattan Project. The primary location of the atomic weapons design was in Los Alamos, New Mexico. Dayton, Ohio was another Manhattan Project site that contributed to the weapons development. It was known as the Dayton Project. The Dayton Project produced polonium, a radioactive element used to detonate the atomic bomb used in the world's first test of a nuclear weapon in the Tularosa Basin in White Sands, New Mexico. It was also used to bring an end to World War II as a component of the atomic bomb called Fat Man, detonated over Nagasaki, Japan. I directed the Dayton Project. Several sites were used in Dayton. The key location was the Runnymede Playhouse in Oakwood, about a mile from here. It was where polonium production took place. Interestingly, my mother-in-law, Catherine Talbot, built the Playhouse in 1927 for family and community events. No one knew that 17 years later, we would be doing highly top-secret work in the middle of a residential community.
With the beginning of the nuclear age, the world would never be the same again. The work accomplished by the top-secret Manhattan Project had triumphed. Allies during the war, the United States and the Soviet Union disagreed on the organization and rebuilding of post-war Europe. Now that the United States also had nuclear weapons on their side, it created an imbalance of power, and these tensions quickly gave rise to the Cold War. The Atomic Energy Act of 1946 ended the military's role in the development of nuclear weapons and power, and placed it into the hands of civilians through the creation of the Atomic Energy Commission. In 1977, all nuclear and energy-related activities were consolidated into one organization, forming the Department of Energy. Polonium-210 was used in the atom bomb's initiator because it is an intense source of the alpha particles needed to produce neutrons to start the nuclear chain reaction. The Dayton Project was primarily concerned with the separation and purification of polonium for delivery to Los Alamos, where the bomb initiators were manufactured. Mount Laboratory continued to process polonium-210 for the use in nuclear weapons until 1972. In order for a bomb to detonate, two subcritical masses of fissionable material had to come together at a high rate of speed using conventional explosives to form a supercritical critical mass. When initiated by a neutron source, the supercritical mass can induce a rapid chain rope explosion reaction, releasing nuclear energy to the explosion. The initiator consisted of polonium-210 and a light metal, beryllium, which when mixed, the resulting alpha-neutron nuclear reaction produced a burst of neutrons sufficient to initiate a chain reaction in the compressed bomb fuel. In 1945, an American-born Soviet spy named George Koval infiltrated the Dayton Project. Codenamed Delmore, he sent significant technical information concerning polonium and more to the Soviet Union. This information allowed the Soviets to test their own atomic bomb in 1949, years before the United States had predicted they would. Koval's espionage was not discovered until the 1950s. Soviet espionage with the United States began before World War II and continued throughout the Cold War. Spies such as Koval heightened security efforts to keep classified information secret. Employees at Mound were often reminded that they were the first line of defense in their country's national security. The nuclear program would continue to grow after World War II. Mound Laboratory. The lead casks were transferred from the guarded rail cars to the underground tunnel in T. A secure facility for slugs were placed into metal buckets and transferred to a pool of water for processing the polonium. Mound Laboratory stopped working with polonium-210 in 1972. Following the end of World War II, political and military tensions increased between the United States and the Soviet Union. This decades-long struggle for dominance became known as the Cold War. They waged this war through regional proxy wars around the world, propaganda campaigns, sports rivalry, espionage, the space race, technology, and most significantly, the build-up of their own nuclear arsenals in preparation for a potential heavily armed conflict or nuclear war. An industry. The Cold War tensions fueled a nuclear arms race between the United States and the Soviet Union as each side tried to gain the advantage over the other in nuclear weapon technology and capabilities. Mound Laboratory worked on a wide range of missions throughout the Cold War as an integrated research, development and production facility in the United States nuclear weapons complex. The vast majority of the nuclear weapons within the United States' current arsenal include Mound research efforts and components. In 1962, Mound developed a method to thermally stabilize detonator explosive powder. In that same year, Mound also began production/fabrication of ferroelectric transducers, explosive fire sets that controlled the initiation of detonators. Mound shipped these components to other sites for testing and weapons assembly. In 1972, Mound was assigned lead responsibility for the design and fabrication of product testers for electrical testing of components. In 1975, Mound opened ceramic and pyrotechnic production facilities, developed moldable ceramic materials, and began production of advanced electronic product testers.